Alright, so we're going to go into exponents and radicals. And the first thing we're going to talk about is actually rewriting these radicals in exponential form. So if you have the fifth root of x to the fourth, you're going to write that in your exponential form. Hopefully you remember that when you're taking this is the same thing as saying if you had, let's say, b value, let's say just x, and a. That's the same thing as writing x to a over b. Okay? So with dealing with that, when you have the fifth root of x to the fourth, and if you just follow that plan right there, you can simply say that you have x to the 4 fifths. Put that x a little bit bigger, so where the 4 fifths looks like it's the exponent. Okay? So 4 fifths is your exponent on that one. So with this one, again, the same process here. I'm not asking anything to anything extra here. We just wanted to put it in an exponential form. So in this case, we follow the same plan that I just described previously right there. Following this guy, we should simply get 3x, all in parentheses, raise the exponent of 5 over 8. And now when you have this, when you just have the square root of 17, again, don't forget square root, there's an understood 2 right there. And of course the 17, there's a 1. 17 to the power of 1. So for this, you take 17 raised to the 1/2. Alright, so that's taking a radical and putting it in exponential form. So now let's look at our exponentials and put them into a radical form. So again, doing the same process that we just did, if you're to think about this, dealing with the symbol, let's just say x raised a over b, that of course is going to put you in to the setup of the b root of x to the a power. So with this, we'll be looking at it simply saying you have 18, and write that out. Let's go and write a radical sign, in which case you should have 10, so the 10th root of 18 to the 9th power. Alright, so we can do the same thing here on this one. So we got a little extra setup here. We got a -1. So, or I should say a -1/4. So we have a negative exponent. And hopefully you remember, if you have anything to a negative exponent, that is the same thing as writing as 1 over x to that exponent a. So let's go ahead and write that in like this before we move any further. So we're going to say 1 over, in this case we have 5x to the 1/4, and then we're going to follow this. We're going to follow this rule after that. Then we're going to follow that and go 1 over, and now we're going to take, in this case, we got 5x still in the radical, but we're going to take the 4th root of that, and of course all this is to an understood 1 value for the 5x. Okay, so now on this one, let's see what we got. We're just going to follow this plan as well here on this one. So we just got a number value to an AB, or A over B exponent. So we can simply just rewrite this. I'm going to write my radical out here. I'll go put my value that we have of negative 125 in parentheses. Again, don't forget the parentheses. And then again, all we're doing is taking the fifth root and taking negative 125 to the fourth power. So that's all we're doing with taking the exponential form and putting it into a radical setup. Alright, so exponents and radicals. So that's all. So now let's look at some actual problems to simplify a little bit further. So here we're going to multiply these guys. So now we got to use our laws of exponents to figure these guys out. So we have x to the 2/3 times x to the 4th. Well, when you do this, your exponent's law here is when you have multiplication, you should then add your exponential powers. Okay? So this is the same thing as writing x to the 2/3 plus 4. Well, what is the trick here in this one? We can't add these values here because we do not have the common denominator. So let's do that. Again, remember this is over 4 over 1. So let's make this a 3. So let's multiply this 4 times 3 over 3. Okay? So we should get whichever x. And now we're still going to have 2/3 plus, in this case, now we have 4 times 3, which is 12, over 1 times 3, which is 3. Now we can go ahead and add those fractions because those have common denominators. So now we have 2/3 plus 12 over 3. Well, now we can just go ahead and write our denominator because it's going to have a 3 at the bottom there. Then we got 2 plus 12, which is 14. And that is the answer we're looking for. Okay? Let's do another one. So when we look at this guy here, we have 16x to the 8th, y to the half, all of that raised to the 1/4. Okay, so on this one, our law of these exponents, when you have everything raised to this, you distribute to everything inside of the parentheses in this case. So you're going to take this 1/4 and multiply that times each exponent for each variable in here. So therefore, I'm going to get 16 to the 1/4. I'm going to get x with 8 times 1/4. And I'm going to get y to the 1/2 times 1/4. Alright, so now let's simplify this. Let's make this a little bit easier to read here. So let's do this. We'll leave 16 to 1/4 right now. So I just want to get these exponents simplified. So 16 to 1/4. And we're going to have x to 8 over 4. And we're going to have y to 1 over 2 times 4, which is 8. Okay? So now we are going to go ahead and simplify this a bit further. So if we're going to take, again, this is taking 16 to the 1 over 4, and the same thing as saying you're taking the 4th root of 16. Well, if you don't have a calculator, there's no problem. Let's go ahead and do our factor tree on this guy, right? So 16, you take 4 times 4, we get down our prime numbers. Well, what gives you 4? 2 times 2, 2 times 2. Well, now you're taking the fourth root, so that means you have to have groups of 4 to pull it outside of this radical. Well, in that case, I have all the prime numbers are 2's, and there's 4 of them. So with that, the fourth root of 16 means I can take out a 2, and that's what that's going to equal. So, therefore, this equals 2. I'm going to write this out so everybody can see what I'm talking about. So 16th to the 1/4 equals 2. So we've got a 2 here. And then we're going to raise this. X is 8 divided by 4 is going to be simply a 2. And then we can't do much else with that y to the 1/8. So we simply just have y to the 1/8 power. And therefore, that is our final answer on that one. So again, we're just having to take these radicals or exponents, however it's set up here, and then actually simplify them further. Let's do a couple more examples here. Okay, so with this one, we have x to the power of 4/7 divided by x to the power of 2 divided by 3. Well, for our law of exponents in this case, when you have an exponent divided by an exponent, then you're going to subtract the denominator from the numerator. So with this one, this is going to equal x to the power of 4/7 minus 2/3. Well, again, to subtract those fractions that we have in the exponents, we need to have common denominators. So with that, let's look at that. I'm just going to write down the fractions here. 4/7 minus 2/3. Well, to get a common denominator, let's say it's 21. So we just multiply these together. Since they're both prime numbers, they can't be reduced any further. So therefore, both prime numbers, so let's multiply this one times 3/3 to get 21. And let's multiply this fraction times 7/7. Okay? So that will then give us 3 times 4 gives me 12/21. And that's minus, and then if I say 2 times 7, that's 14/21. Well, now we can subtract the numerator. So 12 minus 14, well, that's going to be a negative 2. It's all over 21. So therefore, what this is looking at giving me up here is x to a negative 2/21. But now remember, there's another rule here. We have a negative exponent, and you can't have a negative exponent for your final answer on this. So this just needs to be dropped down to the denominator. So in other words, we're going to take 1 over x to 21. So 1 over x raised to the power of 2/21. And this is a simplified fraction for that exponent. Alright, so now we got a pretty crazy radical set up here. And we're going to need to put these in exponential form and simplify from there on this next one. So, with this, let's go ahead and just write this in exponential form to begin with by following our rules of when we have our b root of x to the a power, which will then give us x to the a over b. Okay? So then we're going to have simply here, we're going to have x have 7/3 times x to 2/4. Alright. And then this is all over. In this case, we're going to say x 8/12. Now, before I move any further, I'm going to reduce these fractions. See, that makes it a little bit easier to work with. Because, well, no, in fact, let's not do that. Let's not do that, because I can already see where this may work out a little bit better in our favor. Because if we do this, we should be able to just get common denominator of 12 looks like, and make this all work out nice and pretty. So let's do that. So up top, when we multiply again two variables that have different exponents, we need to add those exponents together. The same variable but different exponents, we add them together. So we're going to have x 7/3 plus 2/4. Well, we still have all that over x, so 8/12. Okay, so now let's get a common denominator up here on this top part of the numerator to add those two fractions. And to do that, let's go ahead and make those 12. So I'm going to multiply this one times 3/3. And multiply this one times 4/4. And that's going to give me up top here, it's going to give me an x. So give me an x. And then up top, I'm going to have 4 times 7, which is 28/12. I'm going to add, and we're going to have 6. 2 times 3 is 6. And then 4 times 3 is 12. Alright, and on the bottom down there, I've still got my x to the 8/12. Okay, so now let's go ahead and take care of that top fraction there. And the numerator, or top part of the fraction, the numerator. So we still have an x up here. And now we should have 28 plus 6 is going to give me 34. So we got 34, and that's still all over 12. And on the bottom, we haven't done anything to this bottom one here. Let's take x, so 8/12. And now you probably can see why I didn't want to reduce these fractions, because now when I go into this process, we're going to need to subtract these exponents. So we're going to need common denominators, which in this case they'll already have them. So let's do that. So if we do this, this is going to equal x, and we're going to have 34/12 minus 8/12. So now we can just go ahead and get our answer. See what we get here. So x, and then 34 minus 8, that's going to give us 26. And that's all over 12. But now we should be able to reduce this fraction a little bit more. And we can divide, let's see, we can divide 2 into both those. So if we divide this number by 2 and divide this number by 2, a numerator and a denominator, we should get x is equal to 13/6. And that is our final answer. Alright, so again with these, the main thing is following your laws of exponents and then reducing, getting it simplified as best you can all the way down to the lowest values. Alright, so hope you guys learned about something today, and I'll see you next time.